All right, today we're looking at L'Hopital's rule. The idea here is if you have a limit which is indeterminate, then that limit is going to be equal to the derivative of the numerator over the derivative of the denominator. Once again, this is only if it's indeterminate. Now this requires going back over some of our indeterminate forms. They're listed down at the bottom here. So 0 over 0, infinity over infinity, 0 times infinity, 1 to the infinity power, infinity minus infinity, 0 to the 0 power, or infinity to the 0 power. Those are all the ones that, that we're going to need to see here. So let's start with an example that we can very easily see. We know the limit as x approaches 0 of sine of x over x is equal to 1. This is one we already know. But it also is 0 over 0. So we're going to do L'Hopital's rule. We have the limit as x approaches 0 of, we'll do the derivative of the top, which is going to be cosine of x, over the derivative of the bottom, which is going to be 1. So that means this limit is equal to 1. All right? Sometimes you might have to do it multiple times. Like, for example, this one. You plug in 2, you get 0 over 0. You'd have to do L'Hopital's rule 2 different times before you got there. So your first L'Hopital's rule, x approaches 2, is going to be 3x squared minus 6x over 4x cubed minus 12x squared plus 14x minus 12. Then you do L'Hopital's rule again, because if we plug in 2, we still get 0 over 0. We have a limit as x approaches 2 of 6x minus 6 over 12x squared minus 24x plus 14. And now when we plug in 2, this is the first time we don't get 0 over 0. And so we could simplify this down. I think it gives us 3 over 7. All right? Sometimes we'll have ones that don't look like the others. So like this one, if we plug in infinity, we get infinity here and then 0 here. Infinity times 0 is one of our indeterminate forms. But L'Hopital's rule only works if it's a function divided by another function. So we're going to rewrite it. I'm going to say this is limit as x approaches infinity of sine of 1 over x over, and then x to the negative 1. Now we have a function over another function, and we can do L'Hopital's rule. L'Hopital's limit as x approaches infinity of derivative of sine of 1 over x is going to be cosine 1 over x times negative 1 x to the negative 2 over derivative of x to the negative 1, or 1 over x, is negative 1 x to the negative 2. Those will cancel. We're left with limit as x approaches infinity of cosine 1 over x. As x goes to infinity, the 1 over x goes to 0, so this is cosine of 0, which is equal to 1. All right? And the last type we're going to look at are ones that require you to do a little bit more. Ones like this. This is going to be indeterminate. It's 0 to the 0. But now we need a way to get this as one function over another. Well, the only way we can do that is something that we've learned before, which is using natural log. So we're going to say the limit as x approaches 0 from the right of y is equal to this limit. And then to get that exponent away from there, we're going to do the natural log of both sides. And when we do the natural log of x to the x, that means we can pull this x in the power down to the front, and then we can rewrite this. We can say this is the limit as x approaches 0 from the right of natural log of x over x to the negative 1. Now it's a function over a function, so we can do L'Hopital's rule. Limit as x approaches 0 from the right of 1 over x over negative, we'll say negative x to the negative 2, but we can rewrite that as negative 1 over x squared, which simplifies down to just negative x. Okay? And then we plug in 0, and we get 0 here. Now, a lot of y'all are looking at this like, oh, 0, that's the answer. But we have this part right here. What we found the limit as x approaches 0 from the right of natural log of y is equal to 0. What we want, if we look back, We want just y. Y was the original limit we were looking for. So to undo the natural log, we're going to say y is equal to e to the 0, or y is equal to 1. So any of these that we do the natural log on, where we're implementing the natural log to get a power down, we're going to have to undo that there. Okay, that's the basics of L'Hopital's rule. Feel free to stop by and ask any questions. Let me know if there's anything else I can help you with. Y'all have a great day.